Good day, everyone. I'm Dr. Chao Xu from Next Generation Wireless Research Group. I'm currently on a Marie Curie Fellowship hosted by the ECS, which also supports my role as a visiting researcher at the University of Tokyo. This video aims to share insights into my current research and plans for the future. I came to Southampton in 2008 and studied MSc PhD before working as a postdoc. I've been fortunate to receive honors at every stage, including Best MSc Awards, Chinese Government Award, Dean's Award. Over the course of my career, I have published 66 journal papers. My research has attracted more than 1,600 citations. An especially rewarding achievement was being the first researcher from the University of Southampton to achieve a perfect score in Marie Curie proposal evaluation. My current research is motivated by a critical global challenge. Only 63% of the world population have internet access, even though almost 88% have already been covered by 4G, 5G. This indicates the urgency in a paradigm shift from pursuing data rate or coverage to the global optimization of the entire network. Achieving this requires a joint optimization over multiple objectives. This is particularly challenging in the next generation space air-ground integrated networks. Against this background, firstly, I propose to develop new waveforms to facilitate the coexistence of radar and communication. Secondly, I propose to develop new materials of reflecting surface to steer signal to the desired direction. Thirdly, I propose to devise a deep learning architecture for the joint optimization over multiple objectives. To elaborate the challenge with any RF waveforms lies in addressing the multipath effect, where the superposition of line sight and non-line sight leads to channel power fluctuations. The 5G waveform OFDM aims to mitigate this in the frequency domain only by Fourier transform. The next generation OTFS mitigates this in both time and frequency domain by Heisenberg and Wegener transforms, so that I can better support both radar and communication. I have recently proposed the world's first non-coherent OTFS, which saves half of the bandwidth by eliminating channel estimation. Furthermore, I have proposed the world's first reflecting surface enhanced OTFS, where the phase change at the reflecting surface is guided by the Doppler frequency. This breakthrough enables the reflecting surface to support any vehicles, even including satellites traveling at Mach 25. Recently, deep learning has been introduced to wireless communication. However, unlike computer science, the wireless environment is highly dynamic in nature, while the computing resource is often scarce. Therefore, I propose the composite model data-driven solutions, enabling the learning algorithm to scale for a large number of input-output signals. Furthermore, we propose to apply DNA weights onto the signals as they propagate through multiple layers of metamaterials. This enables wireless functions to be computed at the speed of light. I plan to apply for new investigator and future leaders grant in line with my short-term career goal. Now, imagine a world where there's internet access and assisted living wherever there's light. The open problem is that the superposition of line of sight and non-line of sight will mislead localization and data detection. To mitigate this, I propose to develop new optical waveforms based on the multi-carrier principles used in RF waveforms. This will enable us to separate line of sight from non-line of sight. This is beneficial because we can exploit the additional information conveyed by non-Lao side that is now separated from the Lao side. Therefore, this project aims to be the first not only to support radar sensing and communication, but also to transform optical multipass from a challenge to an asset. Moreover, quantum key distribution is another key focus in my research. Many critical applications, such as banking, healthcare, require secure communication through wireless channels. This motivates the move from optical frequencies down to terahertz and millimeter wave. The good thing is that path loss and scattering would reduce as the wavelength increases from optical to terahertz. However, compared to the optical band, the photon energy becomes weaker in terahertz and thermal noise becomes stronger. In order to mitigate this problem, we propose to optimize 5G compliant error correction code to empower QKD, especially in terahertz, as part of our effort to promote a global wireless quantum network in time for 6G. In summary, my highly cross-disciplinary research aligns closely with national strategies. Looking ahead to my medium and long-term career goals, I plan to integrate quantum, wireless, and optical communication to pursue larger grants. My long-term objective is to make wireless service available, secure, optimized, and affordable for everyone, everything, everywhere. Since 2021, I've taken on 2/3 of the teaching responsibilities for ELEC 3204. To brighten up my teaching, I connect IT memes to the knowledge. For example, don't trust atoms, they make up everything. I also develop classroom game that involve students to pass lemon to mimic light propagation. I currently supervise 4 PhDs and I have graduated another 3 in the past. I'm committed to taking on more teaching responsibilities and also develop a new module on quantum communication. This new lecturer position will enable me to achieve full academic independence because my research interests are highly complementary to those of the ECS group. This will enable me to build out my team by supervising PhDs from different disciplines. I will enhance my industrial collaborations through patent and grant applications. Moreover, I'm committed to promote EDI in our community. In addressing to EDI, firstly, my research aims to alleviate the inequality in internet access with respect to gender, income, geography, and age. Secondly, I will continue to collaborate with everyone from a diversity of backgrounds, generating a diversity of ideas in both academia and industry. Thirdly, I will contribute to an inclusive community culture through in-reach activities and outreach activities. Finally, let me highlight my proposed contribution to the ECS. Firstly, I aspire to pioneer world-leading research. Secondly, I will contribute to research-led education. Thirdly, I'm committed to embedding EDI into research. Finally, I'm eager to engage in outreach activities. These contributions will be distilled into my short-term, medium-term, and long-term career goals, each accompanied by clear plans for funding applications. It's been a great pleasure and privilege to work in the ECS. I look forward to the opportunity to continue growing and contributing in the future. Thank you for considering my application.